Good evening, everyone. My name is Koshi Arya, and today I'm here to present my internship experience at WebStackAcademy. Before I begin my presentation, I would like to take a moment to introduce WebStackAcademy and express my appreciation for the opportunity they have provided. WebStackAcademy is a platform dedicated to helping students develop practical industry-ready skills through hands-on learning and real-world projects. This internship was not just about learning new concepts, it was about applying them in a professional environment, solving practical problems, and gaining valuable experience. And I'm really truly grateful to WebStack Academy for providing me with this valuable learning opportunity. Now, let me take you through my internship journey, the projects I worked on, and the key skills I gained during this project. So, let's start with the introduction part. This project is a modern, responsive food ordering solution. Let's take an example. Think of a food ordering app like a traditional restaurant. React is the decorated dining area and the menu card where customers sit and choose. Node.js and Express act as the chef and kitchen staff taking orders, and MongoDB is the pantry where all ingredients and stocks are stored. By using JavaScript across this entire stack, we build a unified high-performing system. So let's talk about the problem statement. Why did we build this? Current food ordering apps face major issues like slow page that frustrate hungry users, vulnerable security systems that put payment data at risk, and backend servers that crash during peak hours like lunch or dinner rushes. This project is specifically designed to solve these exact bottlenecks. To solve these problems, my goals were build a clean, decoupled front-end back-end setup, implement secure, stateless JWT session authentication, integrate the secure strip gateway to handle payment safely, and create a clean, scalable folder structure. I'm giving you the overview of the MERN stack. So as mentioned, we use MongoDB for flexible BSON storage, Express as our lightweight backend framework, React for a dynamic single page user interface, and Node.js is our high-speed, non-blocking asynchronous engine room. In our next slide, we have React.js frontend. Our frontend is built entirely using React. Instead of writing heavy static pages, we break the UI into usable Lego blocks called functional components. We use React hooks to manage our variable and states, and React router to change page instantly without annoying browser reloads. So Node.js backend on the backend that uses an event-driven single-threaded event loop. Example: imagine a busy coffee shop. Okay, instead of having one cashier wait the counter for your coffee to brew before serving the next customer, the cashier takes your order, hand it to barista, and immediately serve the next person. That is how Node handles thousands of requests concurrently without blocking. Let's talk about Express.js framework. So Express sits on the top of Node to handle routing, middleware, and API endpoints. It acts as a organized assembly line, like request comes in, passes through security checking, middleware goes to the database controller and returns a clean response to the user. MongoDB database. It is a major role that it plays a major role in our internship project. So we use MongoDB because of its schema flexibility. Okay, so we track four core data collections: user, product, order, and cart. It stores data as JSON like files, making it incredibly easy to update or add new properties, like adding new food categories without breaking the database. JWT authentication. So it describes the JWT workflow. Like for user login security, we use JSON web tokens like JWT. Okay, let's take another example. Think of a JWT like a theme park wristband. Okay, instead of checking a master guest book every single time you want to board a ride, which slow things down, the main gate issues you signed wristband and JWT when you enter. So you just show the wristband at the every ride to get instant access. It is completely stateless, lightweight and secure. REST APIs. Okay, so our front-end and back-end communicate using structured REST APIs. Like the API act like a waiter. So the client, tell the waiter what you want. That means request. The waiter takes it to the kitchen. It's in server and brings your food back. Its response. We have endpoints like get products to fetch the menu and post order to submit a checkout. Slide 12. Folder structure. A folder structure is a folder directory tree. So to keep things professional, the folder structure is clearly separated into a front-end directory for components and pages and a back-end directory for models, routes, database configuration and middleware. Database schema details. Uh, so using Mongoose, we enforce validation on our Mongoose collection. For security, user passwords are encrypted into unreadable hashes before being stored. The order schema tracks items arrays, total order status, and a payment reference ID from Stripe. System architecture. It is a system work diagram. System flow diagram. The system architecture is a clean loop. A user places an order on React, which hits our Express backends via HTTPS. The backend verifies the user JWT process. The card payment securely with Stripe, save the transaction in MongoDB, and tells React to display a success message. User flow. User flow is a user journey. The user journey is simple. They browse the menu, add their favorite meals to the cart, review details on the checkout page, make a secure payment via Stripe, and receive a payment confirmation. Admin flow. Admin dashboard features in describing the slide, like for restaurant managers, we have an admin flow. If an admin logins, they get access to management dashboard where they can order or delete menu products, monitor customer transaction, and track order fulfillment status in real time. Cart flow. Cart flow is a cart state. To make the cart robust, we use a persistent cart state. Example: if a user builds an order and accidentally closes the tab, we serialize and catch the cart in the browser. This is like local storage. When they reopen the site, their food items are still sitting in their cart, ready to go. Stripe payment flow. It's a payment steps. When a user checks out of a backend, tell Stripe to create a unique secure token called a client underscore secret that we write in a code. The front end uses this token to display secure cards fields powered directly by Stripe servers, meaning we never store sensitive character card numbers on your own server. Security features. Security items. We have built in security at every step. Passwords are encrypted, User sessions are managed with signed JWT tokens, and all inputs of forms are sanitized on the server to block malicious hacking injections. Project features. To summarize, the project successfully delivers secure authentication, dynamic menus with real-time filters, a persistent shopping cart, a secure payment process, and a fully functional admin control panel. Challenges. The biggest challenge I faced was managing asynchronous data syncing between the card and database. I'm building a responsive layout for the mobile screens and writing customer logic to handle secure web of payments for Stripe. It is really challenging for me. Learnings. Yeah, it is the major thing I want to share. The career learnings. This project taught me a lot. I mastered full stack JavaScript integration, understood payment workflows, got hand on experience designing robust APIs, and learned to write database queries designed for maximum speed. Future scope. In the future, I have to plan at a real time GPS delivery tracking using socket connection, building a matching native mobile app, and implement an AI recommendation system based on order histories. I want to change these features if I doing this work on this project, and absolutely I'm doing that. I will going to do this. So React component code breakdown. Um, yeah, let's look at the actual code. This is my React component from rendering an individual menu item card. On line 1, we define menu item as a functional component that accepts two incoming JavaScript parameters or props item, data object, and the add to cart function, right? On the line 2, we initialize local component state with the uh, use state hook. It track a variable called QTY, any quantity, which defaults to 0. On line 3 to 6, we defines our clicking handling function called handled. Every time a customer clicks add to cart, the function calls set QTY or QTY plus 1 to update the quantity on the UI. Simultaneously, it triggers add to cart item to add the food items on the global cart start. On line 7 to 15, the component returns clean.js. We dynamically bind the title and the price of food items using curly braces, and we map that buttons on click event directly to our handed functions. This keeps our UI highly interactive and responsive. Express root code snippet. Moving on to the backend, this is my Express router handle for creating a new customer order. I want to share my original codes, but unfortunately, my work laptop is not working at this moment right now, so I'm very sad and I'm so much in pain right now. So I have to share my projects through by this PPT, which is I just copy in the code and I copy here because I don't have a laptop my and there is never. Okay, let's do the uh, presentation. So this is my express router handler for creating a new customer orders. And same on line 1 we register post router orders. Notice that we inject a middleware function called it auth middleware right before the main handlers. And on line 2 we use ES6 destructing to pull the user ID items array and the total amount directly out for incoming request body. On line 3 and 4 we perform crucial backend validation. If the user ID is missing, the card array is empty. We return a 400 bad request. MongoDB query breakdown. Finally, this is my optimized MongoDB aggregation query, which I wrote to fetch a user order history along with the product details in a standard SQL database. That requires heavy table joins in MongoDB. We use a single highly efficient multi-stage pipeline like match for stage 1, lookup, stage 2, and sort, and the last is project. UI mockups and user interface. So because of my laptop's sudden hardware failure, I cannot present a live browser demo today, but these are the mockups of the exact system screens I built. It includes our home screen dynamic menu with category filters and a fully interactive cart page and the integrated checkout forms. Yeah, this is the admin dashboard mockup. I themed it in a high contrast yellow black design. It features analytic widgets at the top of the real time tracking for the sales order volumes alongside structure management tables to let the administrative update product listing and order status instantly. Summary of achievements. Yeah. So in conclusion, this project really successfully implements a modern, secure and production ready food ordering system using the MERN stack. I successfully integrated JWT stateless session, Stripe credit and checkouts, and optimized MongoDB query models. This experience has given me great practice in system design and backend engineering. Yeah, so thank you. That brings me to the end of my presentation. I would like to say a huge thank you to my mentors, Risha ma'am. Thank you so much. And in all the instructors for guidance and throughout the internship. Thank you all for your time, and I'm now ready to answer any questions you may have. And I'm really very sorry about the inconvenient because of my laptop due to an accidental water damage to the original project laptop on the day of submission. The actual project screenshots were unfortunately lost and could not be recovered. Therefore, the UI screens shown in the presentation are realistic design mockups created only for the demonstration purpose. They represent the intended functionality and user experience of the project and are not presented as actual screenshot of the deployed application. Thank you for your understanding.